So I'm going to talk about static initialization of Bitfields in the Plan 9C compilers, and the rationale for this, it's a patch for the compiler, is that the Plan 9C compilers, they don't fully support Bitfields. They do support it somewhat, but in some software, POSIX software, not in the Plan 9 code base, there are other use of Bitfields that in static initialization of Bitfields instructs that does not work in the Plan 9 compilers. And this is one of the things that is in the NetSurf web browser that we had to patch manually to get by this. It's not a big thing, but it's one of the things, and I tried to solve that one, and also in other software like GNU-Make and some other software also use this kind of initialization of Bitfields. So this patch makes it easier to port this kind of software. So Bitfields, for those who are not familiar, is a way of packing more compactly data into a struct to use every bit for something without having to use bitwise and or bit shifting. That's an alternative. So you use integer types, and you can specify how many bits each member of the struct is going to have, and then you can access these members almost like if they were a new kind of data type with a specified length. You cannot take a pointer of them, and you cannot do everything, but you can do like that. And outside of Plan 9, the C language have had Bitfields since the start. I tried to pinpoint if it was not exactly from the start, but I mean, what I understand, it's from the start. But it's not very used generally. Of course, space to compact space is less important than speed, and using Bitfields means that internally it's going to do some bit shifting, which makes it slower than just to take a full integer, for example, the machine word. And another problem that limits the usefulness is that the layout, exactly how it is compiler dependent. So the standard C standard doesn't specify exactly how these Bitfields are going to lay it out, and that means that they are less useful for specifying protocols like network protocols or interfacing with hardware by bit. And in Plan 9, so it's supported to do runtime initialization. You have Bitfields, and you can assign them values. So it means that this will generate code which shifts in the right values into the thing. But you cannot just take a struct here, bf2, and assign it a constant array of values that gets into the right Bitfields of a struct. That does not work. And generally, it's not Bitfields are not at all used in the Plan 9 core, but it's used in, for example, Ghost script and audio players. That's in the things that are shipped with the system. I was looking in 9 front. I think it's similar for generally. And the probable lack of the support. Why didn't Ken Thompson, or who was writing the compiler, implement this? And it's of course it's not needed. Maybe in the Plan 9, so and it's maybe not so much used. But a probable reason is also that it's kind of a little bit tricky, because when you have an array. Normally in Plan 9, these constants, every member of the structure generates one data line or multiple data lines if the constant is more than 32 bits. But it's not like one data line is for two members at the same time, which is a requirement for Bitfields, because the whole idea of a Bitfield is that you can map multiple values into one 32-bit constant. So to do that in the compiler require either backpatching or look ahead. So to construct these constants. So that is my assumption. That is why they left it out, to make it simpler. So I made an implementation which uses backpatching these 32-bit constants in the output tree of the compiler. So if you have a struct and and here are some different members, and here comes the first bit field, and then comes 6 bit field, and then comes something else. So when it comes to the first bit field, it generates a 32-bit constant, and the right bits are set into that constant for that one, and the other are left 0. And then when if it comes to another bit field, that would fit in the first constant. The first one is backpatched, the first constant, and until it comes to a overflowing, like there is the next one, I should go into the next constant, so a new constant is generated, but like that. And this backpatching is simply done by keeping a pointer to the last 32-bit constant in the output tree, and then so then the data lines are generated and sent to the assembler after. So it's from this data tree automatically. No change there needed. And the pros and cons of this current implementation is that the advantage of this patch is that it's what I can see is the minimal patch. It's like it changes as few lines of the compiler as possible to make this. But it has a drawback that it requires a separate modification that is similar, but in every architecture it has to be made the change for them to work. It's not possible to just do it in one place, but it has to be done in multiple places. So I made it for those architectures that I currently can run on 9 front. So it's ARM64, ARM64 and 386. It's made on that one, those. But if a new architecture is added, it has to be added there too. So it's and I mean, usually you just want to make a change in one place if possible. And all these architectures happens to be little endian, which means that the patch is even smaller, because for a reason I will just come into. And the thing is that this pointer is a pointer to a long to this 32-bit word. So, but in the 64-bit architectures, this the member, the variable that keeps this 32-bit constant is a 64-bit memory position. So even if it can never be more than 32-bit, because the constants are only up to 32 bits. So it works for anyway, because it just writes to the lower 32 bits. So in this way I can keep, I just have to change, in the other part, like SVT, this is for every architecture, and the DCL, the one that is the receiving part, it's the same. It keeps the same as no changes. So, but it's if to make it for big endian, so it have to write a little bit more code, but still. So the patch, this is just the patch description. It's on my GitHub page. And also, it's included in Ape XP. It's an experimental new Ape environment that is Jens Ståhl is making, and he has included this patch into this ape, which also includes the compiler. And his aim is to make ape that can environment that can compile more kind of software into Ply 9, and also to experiment with these kind of things without having to things have to go into the main compiler. Maybe it's not wanted to be there because it's just for porting software. So that's where it lives. So discussion is this kind of thing would it at all be interested to have support for this kind of thing in the mainstream compilers? It's a little bit I mean, it's not used in the Plan 9 system, but it's used for compiling POSIX software. So and it's part of the C standard. So but many things are part of the C standard that is not supported. So it's not. And also, I'm a little bit curious. If there is maybe someone has an idea of how it can be made architecture independent, because I didn't figure that out myself. If there is a nicer way of doing that. So that are my discussion questions. So maybe you have other questions. Anyone? Yeah, they don't like Bitfields like that.
Lots of reasons for that, but it was a slightly later addition to C rather than from the start. It was added for as I remember it was added for a particular project. A particular group wanted it, and that's why it has so many bad edges, really. If you were doing it now, you would at least have the ordering consistent somehow, so that you don't have. So you could describe protocols with it.
Yeah, that makes sense.
In some ways, that would probably be the most common application of it if it worked. And instead, you have if-defs, bracketing, each stuff that goes each direction. So it's useful to get it fixed in a way, because it's slightly annoying for it to be there, but not actually work very well.
For the presentation, very interesting, and actually made me think this how to make it architecture independent. The problem, like I'm thinking, looks like just pushing bits down to a shift register. So maybe like something abstract, making like push this many bits into the register, maybe using the architecture independent equivalents, just a common shift and end and or operations. Make it a VLONG, probably let the compiler handle it, and that maybe actually simplify it. And thanks for the net surface, by the way.
Basically just echoing, I don't see any reason why we wouldn't want to commit it to the compiler, given that it's not a big change. And I think I'm not familiar enough with the code off the top of my head to say that we can make it architecture independent, but I wouldn't be surprised. There's a lot of stuff. It might be a bigger change because the compilers tend to have a lot of stuff that's copied and pasted, where we could refactor it to be. There's a lot of the architecture-specific parts of the compiler that shouldn't be architecture-specific. We should fix that. I think that's the short summary. And the way I would do this is first just commit this as architecture-dependent and then start refactoring.
I'm going to be a terrible man and take the opposite position. And you know, historically, the reason that Bitfields were hated is because people would pack registers that way for hardware access, and this caused endian stuff to get encoded into whatever applications you had, and now you're in the world of if-defs and figuring out what you're doing with your endianness, and it gets crammed through the bit fields. So they wind up being, hardware or endian dependent and architecture dependent in horrible ways. And so part of me, being contrarian, would say, why don't we just get rid of bit fields? And that way this compiler could be simpler. And anyways, they are useful, but there's a reason that we don't pack them generally. So anyways, there we go.
So my other idea is that I've read the patch, and the thing is that the architecture independent code calls a function gextern, which is architecture dependent, and once it's called, it's done. The data line has been emitted, written, whatever, but we can defer calling this gextern until we know what exact value is the composed from all the bit fields that compact into this single memory location. So we can act not call gextern on the first one and then retroactively patch the thing that is inside this structure that is already printed or something. But we can first construct it so that the value is correct, and then once it's done, so the moment we encounter non-bit field or the structure closes, we can emit the bit field that is pending.
Okay, yeah, it's a good idea. Yeah.
Is the C standard requiring the packing of the bit fields?
It does, yes.
It does require?
It does require packing, yeah.
In this case, for the big endian and 64 bits, since you will emit only when you have completed the pack, can you simply temporarily consider the packing like little endian, and once you have everything, swap the definition of the bit fields to be in a big endian order?
I mean, the constant is always 32-bit maximum. In Plan 9 compiler, you cannot have a bit field that is more than 31-bit or something like that. It's maximum. So I think generally the endian is not a problem. It's not to be used for communication, like where with different systems, I think. But that's and actually the format is specified. Like if you have a struct with bitfields in the compiler, it's done. Like it's not like it's not defined. So when I calculate this, I just have to calculate it in a way that is compatible with the runtime, because in runtime you can set these values and it will know where it is and this how it packs it. It's well defined in this compiler in Plan 9. So even if it's not set in the standard, so I suppose it's possible to do in different ways, because the C standard doesn't say, but the compiler do in one way.
On all Plan 9 compilers, long is 32 bits.
It's the bit field, you cannot have a longer than 32-bit, 31-bit bit field.
The long value is 32 bits in every compiler, including 64 bits.
Yeah, it is, but they use VLong in the 64 bits to hold the value in the
okay.
I mean, it's a general register that can be used for different things. So it's not. It just happened in this case that it's used for Bitfields, but it can be like it's called vconst. So it's something like that.
Right, and we got another last remark from the chat. Someone hasn't heard of Bitfields in C before, and they're saying it looks a bit like, or feels like a mix between structs and unions. Do what you want with that remark.
Yeah. I think you can have Bitfields in unions too. So.
So I can only say from my side, I do lots of firmware stuff, and I deal a lot with registers, which have very fancy bits in there for all sorts of stuff, and it's very handy sometimes to have Bitfields. Anyway, that's it, I suppose. Then thank you very much.
Mm-hmm. Right, thank you.